Welcome to solverfy.
So for this question, we're given that Stein Corporation wants to find an equation to estimate some of the monthly operating costs for the operating budget for 2018, and the costs that we gathered for 2017 are given throughout the whole year, with the maintenance cost, the maintenance hours, the machine hours rather, the health insurance, the number of employees, the shipping cost, and the unit cost. Now, the first question wants us to find which of the preceding cost is variable, which of the preceding cost is fixed, which is mixed, and which is variable, fixed, or mixed, and what to explain. So, looking at the table, the cost that is fixed, the preceding cost that is fixed would be the health insurance cost, and this is because the health insurance costs do not vary with the number of employees, and therefore they remain fixed. So we're going to say the health insurance costs are fixed because they did not vary with the number of employees. And it remains fixed. Now the preceding cost that is mixed would be maintenance costs, because maintenance costs have a fixed component of the supervisor, the maintenance salary, and the staff salary. But it could also have a variable cost component that varies with the machine hours. So basically the machine staff salaries, which you pay the staffs, are fixed and they do not change. But at the same time, the maintenance costs could also vary due to the machine hours that are used. So maintenance costs are mixed. And they are mixed because they could be fixed due to maintenance staff salaries and variable due with the machine hours used. Now moving on, the costs that are variable are the shipping cost. Shipping costs are variable costs and they vary directly with the units that ship. So the more units you ship, that's what's going to change the shipping cost. So they're all variable. So shipping costs are variable and depends directly on the units shipped. Now that's just the first part of the question. Now the second question says, using the high-low method, determine the cost function for each cost. So for the cost, if the costs are given by y and the cost driver are given by x, Then the cost function will be equals to the cost function formula will be given by the following with the slope of coefficient b and the intercept of a as y is equals to a plus bx. So now for the cost, we're going to let the highest cost be YH and with the cost driver of XH. So let the highest cost value be YH with cost driver value of XH, and the lowest cost value BYL with cost driver value of XL. So the slope coefficient B will be given by the formula under the I-low method. The slope coefficient to be B equals to YH minus YL divided by XH minus XL. So the intercept A would be the intercept A under the I-low method would be A is equals to YH minus, so this is a slope coefficient and this is the intercept. So it will be YH minus B multiplied by X, and I can make this a small multiply XH. So now we're going to calculate the slope coefficient B for health insurance cost, given the highest cost of 8,600 and the number of employees of 105 and the lowest cost of 8,600. So basically the slope coefficient. So for the health insurance costs, so the highest cost value is 8,600 and number of employees is 105, and the lowest cost value for health insurance cost is 8,600 and the number of employees is 68. So therefore the slope coefficient B will be equals to YH minus YL divided by XH minus XL, and this is equals to 8,600 minus 8,600 divided by 105 minus 68, and this is $0 divided by 105 minus 68, which is still going to be $0. So the slope coefficient B is $0. So now moving on, we're going to calculate the intercept A for the health insurance cost, given the highest cost value of 6,000 and the number of employees of 105. So the intercept of A would be YH minus B multiplied by XH. So the intercept A for health insurance cost to be 8,600 multiplied by 0 minus 0 multiplied by 105, and then A is equals to $8,600. So therefore the cost function for health insurance cost is 8,000, y equals to 8,600. So cost function for health insurance cost is equals to y is equals to $8,600. So now we're going to calculate the slope coefficient B of the maintenance cost given the maintenance cost given the highest cost value of 5,271 and hours machine hours of 510, and the lowest cost value is 4,452, and the machine hours is 120. So the slope coefficient B would be YH minus YL divided by XH minus XL. So this is 5,271 minus 4,452 divided by 510 minus 120. So this equals to 819 divided by 390, and then B is equals to $2.10, and that's the slope coefficient. Now to calculate the intercept A for the maintenance cost with the highest value of 5,271 and the machine hours of 510, the intercept A would be YH minus B multiplied by XH. So A would be equals to 5,271 minus 2.10 multiplied by 510, and then A will be equals to 4,200. So the cost function for maintenance costs is equal to Y is equal to 4,200 plus 2.10x. So now we're going to calculate the slope coefficient B for the shipping cost. So for the shipping cost, the highest cost value is 34,596, and the unit shipped is 9,610 units, and the lowest cost value is 20,124, and the unit shipped is 5,590. So the slope coefficient B would be B equals to, using the same formula, YH minus YL divided by XH minus XL. That will be 34,596 minus 20,124 divided by 9,610 minus 5,590, and this is 14,472 divided by 4,020 rather. So the slope coefficient B is equal to $3.60. Now I'm going to calculate the intercept for the shipping cost with the highest cost value we're given at the unit shipped. So the intercept A would be YH minus B multiplied by XH. So A would be equals to 34,596 minus 3.60 multiplied by 9,610, and then A is equals to $0. So the cost function for the shipping cost is equals to y is equals to $3.60 x. So now moving on to the third question. Combine the preceding information to get a monthly operating cost function for the Stein Corporation. So we're going to let the monthly operating cost function be C. So when the number of employees are given by x1, machine hours are given by x2. So number of employees are given by x1, machine hours are given by x2, and then the units that shipped are given by x3. So we're going to use the preceding cost functions to estimate the monthly operating cost function with the monthly operating cost function for health insurance. So that would be C1. Now the monthly operating cost function for maintenance cost would be C2, and the monthly operating cost function for shipping cost would be C3. So C1 will be the monthly operating cost function for health insurance cost. And then C2 will be the monthly operating cost function for maintenance costs. And then C3 will be the monthly operating cost function for shipping costs. So the formula for the monthly operating cost function will be C is equal to C1 plus C2 plus C3. So C1 is equal to 8,600. C2 is equal to 4,200 plus 2.10 x2. And then C3 is equal to 3.60 x3. So C is going to be equal to 8,600 plus 4,200 plus 2.10 x2 plus 3.60 x3. So C is equals to $12,800 plus 2.10 x2 plus $3.60 x3. So therefore this formula will be the monthly operating cost function for SC. So this is the formula. So moving on to the final question. So next month, Stein expects to use 400 machine hours. And 80 employees. And ship 9,000 units. Now estimate the total operating costs for the month. So given the information we're given, the operating costs would be C, right? So that will be the function will be 12,000 from the previous question, 12,800 plus 2.10x2 plus 3.60 cents x3. Now the operating cost to be 12,800 plus 2.10 multiplied by the x2 is 400 because it's the machine hours, multiplied by 400, then plus 3.60, and x3 is the unit shipped, so that's multiplied by 9,000. So C is equals to 12,800 plus 840 plus 32,400. So we can say that the C is equal to $46,040. So therefore the monthly operating cost for the entire month is $46,040, and that's the answer.